So what I want to do today is something a little bit different, but it's very similar to what we've been up to. Last class we went over difference of means test, and we used the example from the textbook about how long does it take to leave a parking spot if somebody's stalking you and waiting for that spot versus when nobody's around. One of the things that the book doesn't cover is how to do something similar to that using proportions. So we're going to go out of the book today, and I'm just going to, it's very similar, but I'm just going to go ahead and teach it to you using an example, and so you'll have to pay attention. I'll try to write up a sheet, like a worksheet on how to do this, and put it up on Moodle this afternoon. But let's get started. So what I wanted to do was to think about, well, what if you have a question that's not a numerical mean, right? So we don't have the number of seconds that it takes for you to leave your spot. What if our question is something like this, a proportion? So what I did is I went through the GSS for class and just said, all right, let's look for something interesting. And I found a variable called jokes work. Are you the target of derogatory comments or jokes at work? So you're asking somebody their experiences. Now, other than students making fun of me at Coastal, nobody has ever sort of done anything to my expense. However, when I worked in a paper mill when I was in college, let's just say there were some guys that liked to draw anatomical body parts on your safety equipment. Jake got it. All right. I thought it was all fun and games till I put it on the side of their work truck one day. And then they left me alone. All right. So, I'm talking about drawing dicks on things, okay? If you haven't gotten that far yet. All right. So, I saw this question. I'm like, I remember this. I can do this one. So I'm like, well, it could also be another meaning, right? Imagine if you're a woman and people are making really awkward things about your dress or your physical appearance, and you're kind of like, I'm just here to do a job. Okay. So I wanted to take a look at this data. Now, I ran the table by gender, so males and females, and the question says, well, how often? Often, sometimes, rarely, or never. Well, I want to make this simple. So I collapsed the yes, people have made derogatory statements about me at work versus the no. So what I did was I took all of the often, sometimes, rarely, and combined them together. And then the nevers are the no's, right? Because no, nobody ever makes jokes about me at work. So the yeses and the nos, and then we got the total. Now, what proportion of men get made fun of at work? Okay. And according to the calculator on my phone, 183 divided by 566 equals 0.323. Let's go one more, 3. So 32% of men in this survey reported that they were made fun of at work. Let's look at women. 122 divided by 560. $2,179. Wait a minute. How is it that men are made more fun of at work than women are? There's more men? No, we're talking about the proportion, right? So it's only off by 6 too. I mean, come on. Right? But we've controlled for that when we did the proportion. Women are less harassed at work than men are. There we go, right? So there's this fear that if you make fun of a woman, then, Title IX is going to come along and I'll be out of a job. Aaron? And I'm not repeating that to be recorded for all posterity. But Aaron says men are less emotional and therefore what?
Less likely to be
Yeah, you keep affected by it. But again, this really isn't affected. This is just saying, some random stranger is saying, hey, you get made fun of at work, I guess. Any other theories? Men are just immature. That's the one I'm really looking for, right? Right? Men are just really immature, and therefore they're more likely to joke around with each other. Okay, I'd buy that. But let's see, does this difference, because we only have a sample, right? And we learned in this class who your sample is really important. So can we sort of see whether or not this difference that we observe in our sample would be a difference we would expect to see if we had a different sample or a different even population? So in order to do that, we have to do many of the same things that we would do. We've got our values, right? So we have our proportions. Now, some books use P. And I think our book that we're using uses a lot of P's. Other books use pi for proportion. Let's stick with the P here for this example. So we have a probability of males and females. We can also call these group 1 or group 1 and group 2. What we're interested in is the difference. All right. We want to know, is there a difference in the treatment of group 1 and group 2? Now, if we're going to construct a null hypothesis around this, what would our null hypothesis be about this gender gap in horseplay at work? Okay, so the null hypothesis is always that there is no difference. Right? And our alternative hypothesis? That there is a difference, that it's not equal to 0. Other ways in which you could have an alternative hypothesis? Okay. So if our alternative hypothesis is that men, because they are so immature, they are more likely to make fun of each other at work, that would give us a positive difference. And the alternative would be that since men are the majority and they get away with a whole bunch of stuff, they would probably pick on women, because we're pigs like that. And then you would say that that difference should be negative, right? Women should report more work harassment than men. Okay. So you could have other alternative hypotheses. Again, these would be one-tailed test. You would have to take the significance level and pack it all in one of the tails. But I like to keep this as simple as possible. I just want to know, is there a difference? Okay. There's one more thing we have to compute. That's called the pooled estimate. We need to know what would happen if you took all of these cases and pooled them together. And the pooled estimate is equal to P1 plus P2, or not, excuse me, let me take that back. How do I want to write this? Come on. Our pooled estimate is all of the positive successes. All right, so it would be the 183 plus the 122. Divided by the total number, which is 566 plus 560. So our pooled estimate, so you got your pie with a little hat. $305 divided by 1126. Okay. So what does that number give us? Well, it gives us the overall proportion of everybody who's been harassed at work. Make sense? So pooled estimate is when you take your various groups in your sample and add them all together. We're going to need that number. Okay, so let's go through this. So far we've got P1, we've got P2, we've got our pooled estimate, and that is 3233. Our group 2 is 2197. And our pooled estimate is 2709. What was our N? 1026, right? No, 1126. Sorry, you were right. N is 1126. Okay, yeah. So if we had to choose between using T or Z, which one are we probably going to use? Z. Okay. And you guys are well trained in doing Z-scores, right? What is a Z-score usually? Something minus something over something, right? Divided by squiggly thing. All right, some sort of measure of variance. Usually, lately, it's been something known as the standard error, right? Where you take the standard deviation divided by n. All right. So generally speaking, what we have is our sample statistic minus the population statistic divided by the standard error. Same thing here with the proportions. But we're talking about differences, right? And we're talking about the difference between the two groups. So what's the difference between sample 2 and sample 1? Well, we know that because we have our two values of p. Right? We know that there is a difference. What is the hypothesized difference between the two proportions if the null hypothesis is correct? 0. Okay. That's great. It's great when you always set up your null hypothesis to be that there is no difference, because then the difference is always 0. Right? We expect in the population that there is no difference between the rates in which men and women are harassed at work. Standard error. Wait a minute. You haven't talked about variance, one of you are thinking. Well, that's okay. Because when you're dealing with proportions, the whole variance thing doesn't quite work the same way. Right? We did this before when you did the p times the 1 minus p, and we showed how variance kind of works strangely. And I hate to do this to you. But we need something here in this case that's called the standard error of the pooled estimate. There's always that one step where I'm like, I'm going to show them this and they're going to be so pissed at you. And here's what it looks like. And it has to do with this thing. So we computed this pooled estimate for a reason. I don't just do this stuff for fun, like, hey, let's do random math for fun. You knew we had to use it somehow. So the pooled estimate's going to come in when we figure out how much variance there is in the sample. Relax, it's not that bad. Now it's bad. Okay. Sorry, I had to do it. It's just, it is what it is. The pooled estimate times 1 minus the pooled estimate. All right, so let's do that part first. Because I'm using my phone calculator, and yeah, I can't use all these parentheses. So this number is 7291 times 2709. So let's do that one first. Okay, not bad. Just multiplying numbers. Now we got some fractions. The number of the two groups, one was 566, one was 560. Probably wrote those backwards, but who cares? 1 divided by 560 is a really, really small number. And 1 divided by 566 is slightly the same. Okay. So I'm going to add those together. Oh, I don't even need the calculator for that. That's 0.0036 times my 0.1975. And I'm going to get a really small number. That was a 1975, right? Good. And now I got to take the square root of that. So you got to turn your phone sideways to get the little square root sign. And I need the square root of 0.000711. And that looks like a real number, 0.0267. Now what do I need this for? I need it for that, all the way up there. Because I'm trying to find a z-score. Okay. So let's do my subtraction that I've got up here. Clear. 0.2197, which is the proportion of females, minus 0.3233 is 0.1036 minus 0. So I got a negative 0.1036, and I'm going to divide that by the standard error of the pooled estimate, which is 0.0267. And the answer is a negative 3.88. Okay, so you got a z-score of almost negative 4. Before we sit down and do all the critical values, what do we think we have here? I'm leaning towards we're going to reject the null, right? Because that's a really big z-score. So if the difference between the two groups in the population is hypothesized to be 0, and we get a negative 3.88, if we did this the right way and did our decision rule first, we could say, well, it's above 1.96. Is 3.88 even in the chart? No. How big does the chart go up to? So what's the area at 3.4?
3.49
Is
the biggest one.
Yeah.
0.0002.
Okay, so 0.0002. So the probability is even smaller than that. I'm feeling 3 stars on this one. Okay. So what do we do with that? We reject the null hypothesis. If we wanted to, could we have a directional alternative hypothesis that men, because we're children, are much more likely to engage in attacks at work? Could we do that? So if we took that 0.05 and moved it all into this tail, right? Could we reject that the null hypothesis and lean towards accepting a directional hypothesis? You guys are all looking at me like you have no idea what the hell I'm talking about. Yes. Okay, 50-50 shot. Why, Jake? Okay, so the probability that you would get this difference if in fact there is no difference between men and women being harassed at work is really, really, really small. Okay. So what's the hard part of this? The standard error, right? That's really the hardest part. Is this thing where you have to first find the pooled estimate, subtract it, and then multiply 1 over n1 plus 1 over n2. That's really it, right? That's the hardest thing. And then you remember that z is your difference see, this is where you really should use the p's. Let's do p divided by. That's it. It's the exact same framework. It's just a slightly different way of getting z because of that standard error. So proportions are just a little bit more difficult. There's that one extra step when you have to pool the estimate together. But other than that, it's about the same framework, right? The difference in what you observe from what you hypothesize if there is no difference divided by the standard error from your pooled estimate. Right? So one additional step, and you can do this difference of proportions test like you can do difference of means testing. Okay? All right, we got 20 minutes. Here's your assignment. We're going to do one more together. Fire up the sda.berkeley.edu and somebody find a really, really good one. sda.berkeley with a whole bunch of e's in it .edu. Whichever one you want. I think the GSS has the better questions, but you know, find something good. It's in archive. There you go. Should be coming back to you. Shiny gold star for somebody who finds a good one. Lord knows some of you can eat it. Don't blame the internet, Joey. It's so slow. There you go. What's that?
Has sexual pleasure strengthened faith?
Oh, that's a pretty good one. That's in the lead. Somebody's got to be able to top that one. Is that a yes or no question?
Often, sometimes, never.
Often, sometimes. Yeah, I could turn that into one. What do you got, Ben? Okay. Catholic rosaries are superstitious. Is that a yes or no question?
I strongly agree.
Okay.
Whether or not sexual materials lead people to commit rape. Porn makes you rape people.
I'm staying away from that. That's a bummer. It's a Monday. There's only so much I can take on a Monday without having to deal with sexual assault.
How is it violent on Jews?
No. Just no. And you get minus points for even saying that out loud.
I didn't ask you.
Yeah. How much information do you have about the pornography issue? How firm are you about your opinion on pornography? Do we have to be like no porn, no drugs? Like, all right, last call. Who's got a good one? Aaron, what do you got?
I just need to see like how they answer it.
So when you click on it and hit, it'll populate up here, and you hit the word view.
But
It's like scale.
yeah, it's good.
No, I'm not doing that one. What do you got?
Like this word,
Nah. What do you got, George? You're smiling.
It's a yes, no.
Okay.
The last time we had sex was a condom used.
No. We're getting warmer, though. What do you got, Ryan?
Is extramarital sex wrong?
All right, let's go with that one. What's the name of the variable?
XMAR SEX.
Okay. What about a married person having sexual relations with someone other than his or her husband or wife? Is it always wrong? Almost always wrong? Wrong only sometimes, or not wrong at all? All right, let's take a look at that. Now we're going to have to combine these, right? So I'm going to combine the always, almost, and sometimes wrongs together. Does that make sense? And then you got the not wrong at all people. All right, let's do this by gender, because I've already got that variable up. XMAR sex. Okay. Now when you pull this data, right, I'm asking it to take this variable and put them in a table together. There are lots of options down here from what you can get from the SDA website. One of the things that they can do is actually use a system of weights, because if they have a sample that's too heavily female or too heavily male or by race or whatever, they can employ a system of weights where they can take the proportions and adjust them based upon getting the sample to match the population. I don't like to do that. I want the unweighted number. Okay. And for percentaging, I think a total will work, because I'm just going to end up doing the math myself anyways. So let's go ahead and run that table. Okay. you get two numbers. You get the percentage, so 32.9% of the sample were men who think that extramarital sex is always wrong. I want the raw number. I want this 1631. Because for men, I'm going to take the 1631 add it to 393, add that to 162. Okay. And I'm going to divide that by 2252. Oops, can't do it that way. Have to enter first. Divided by 2252 equals so the proportion of men who think that extramarital sex is always wrong is 9707. Okay. Let's look at the women. We've got 2466 plus 356 plus 125 equals 2947 out of 2983. So for group 2, it is 98.79. So those are really high numbers. Okay? But women think that extramarital sex is wrong more than men do in this sample. So let's go ahead and do it to see what it would be in the population, or at least if this difference compared to what we would expect to see in the population. So I got to do the pooled estimate. Okay. The pooled estimate is the number of people that the total out of the total that are our category are yeses out of the total number. So 49, and I know you could just do this a lot quicker by only doing the no's, but this is easy math. 4097 plus 749 plus 287 equals 5133 divided by 5235. Okay, and so our pooled estimate is 9805. So what's the first thing we need to do? Okay, so let's look at the difference. 0.9879 minus 0.9707. Our null hypothesis is going to be that there is no difference. And we're going to divide that by the standard error of the pooled estimate. Here we go. Which is equal to the square root of 0.9805 times 1 minus 9805. 1 over plus 1 over. Okay. Well, this is really 1 over the total number, which was 5235. So let's clear 1 minus 0.9805 equals times 0.9805 equals a really small number. We've got 1 divided by 5235. That's a really, really small number. Times 0.0191 equals a number smaller than that. Yeah, I had to write out the entire length of the number, because otherwise it won't mean anything if I shorten it. The square root of 0.000036485 is 0.00191. Okay. So now we have our 0.9879 minus 0.9707 minus 0 equals 0.0172. Let's divide that by our z-score is 9. What does that mean? We're going to reject the null that there's no difference, and we're going to say that, believe it or not, even at such high levels, there is still a difference between how men and women think about having an extramarital affair, and that women are less tolerant. Really hope I dropped a decimal pointer somewhere. I'll have to go back to my office and be like, really? 9? That's huge. You wouldn't expect it, right? Because they were so close together. Okay. So A, I'm going to double check my math. And B, if it holds up that the z-score is 9, I know the chart doesn't go up to 9. So we would put like 18 stars on that one. So there would be a difference between men and women. Okay? Like I said, I'm going to go back up to my office. I'm going to write out a nice sheet that has this nice and clean for you because it's not in the textbook. And this is how you would do a difference of proportions.